So we're in section 5.3. Section 5.3. And this section is entitled the binomial distribution. So if you go far in probability or statistics, there are lots of different discrete probability distributions. That's what we've been looking at, right? Discrete probability distributions. There are a lot of special ones. There's one called the geometric. There's one called the hypergeometric distribution. There's one called the negative binomial. There's one called the Poisson. One called the Bernoulli distribution. Oh, I didn't even write that out correctly. I'm going to rewrite that. So we're not going to really focus on the ones with the red check marks. We're going to focus on the binomial. That's the one that we're going to focus on. We're not going to cover any of these other distributions. I mean, if you want to go further in statistics, probability theory, you can study those other ones. Maybe you want to do it on your own time. But we're just going to focus on the binomial. It's a pretty big one. So to define what a binomial distribution is, we want to talk about a binomial probability experiment. What is a binomial probability experiment? So remember, a probability experiment involves doing something where there's chance that determines the outcome. There's chance. So you have well-defined outcomes determined by chance. So specifically, a binomial probability experiment is a probability experiment that has the following characteristics. So first of all, you have a fixed number of trials. A fixed number of trials. And the number of trials is what we call n. So let's say I'm tossing a coin 5 times. The number of trials would be n equals 5. Let's say I have a 6-sided die that I'm rolling 3 times. My number of trials would be n equals 3. Let's say I have a deck of cards and I draw a card from the deck. Let's say I have 4 draws, and I put the card back in the deck. 4 draws, and I'm replacing the card after I draw. Then my n would be 4. My number of trials would be 4 because I have 4 draws. So the number of trials is what we call n. So you have a fixed number of trials. Number 2, for every trial, you only have 2 outcomes. You have success or failure. So maybe in the case of rolling that, or what did we say, tossing a coin, the first one? Tossing the coin, maybe we're interested in getting heads. So heads would be our success, and our failure would be tails. So you got success versus failure. So in the case of rolling a die, if we're interested in getting a 6, our success would be a 6, and our failure would be everything else besides a 6. 1, 2, 3, 4, 5. In the case of drawing a card, maybe a success would be getting an ace, and failure would be then everything else, everything we're not interested in getting. So everything besides an ace. Okay, so that's the second big criteria. You have to have 2 basic outcomes. Success, what you're interested in getting. Failure, what you're not interested in getting. And number 3, the third criteria for a binomial experiment is the probability of success has to be the same for every trial. Every trial has to be the same. So I'm tossing a coin multiple times. The probability of heads has to be the same every time. When we're rolling a die and we're interested in getting a 6, the probability of getting a 6 has to be the same every time. If I'm drawing from a deck of cards and putting the card back in after we draw, the probability of getting success in ace has to be the same every time. All right. So when you take the number of successes from a binomial experiment, this forms what we call a binomial distribution. The number of successes, if you call the number of successes x, so let's call x the number of successes in a binomial experiment. So x is a variable that tells you the number of successes. The number of successes from a binomial experiment. And x is going to be distributed in what we call a binomial distribution. Binomial distribution. Okay, so x tells us our number of successes. N, we said, was the number of trials. P is going to be the probability of success for each trial. Probability of success on each trial. All right, so I think that's everything we really need. We can also talk about Q. We won't use Q initially. That would be the probability of failure. So the probability of not getting a success on each trial. Now, I think that's all we're going to need for this section. So X, N, P, and Q. Okay. So I guess I'm going to show you, well, let's do some examples just to get started. So identify N, P, Q. Oh, let's do X as well. X, N, P, Q. In the scenario below. Okay, so number one, a coin is tossed 5 times. We are interested in how many heads we get. So if you toss a coin 5 times and you're interested in how many heads you get, you want to identify these different things. So number one, X represents the number of heads you get. Okay, N is the number of trials, which is what? You have 5 trials. So N is 5. P is the probability of success, right? You're interested in getting heads, right? So you have only one way to get heads, if it lands on heads, out of what? 2 possibilities, heads or tails. So 1 and 2 is your chance of getting heads. That's your probability of success on a single trial. Remember, this is on a single trial. So P is the probability of success on a single trial. So you call that 0.5. And if you wanted to find Q, probability of failure, you always take 1 minus P to get that. 1 minus 0.5. That's going to be 0.5 as well, right? Well, that makes sense. I mean, if you have a 50% chance of success, you have a 50% chance of failure for heads. Okay, so that's everything right there. X is the number of heads you get. Number of trials is 5. Probability of success is 0.5. Probability of failure is 0.5. All right, number 2. Let's talk about another scenario. A heads. Let's do a 6-sided die. A 6-sided die is tossed 3 times. We are interested in how many, how do you spell many? Get it right. There we go. 6s we get. We start off with X. So X is the random variable that measures how many 6s you get. So how many 6s? So the number of 6s. All right. N, that's the number of trials. How many trials do we have? Well, we have 3 trials, right? We toss our die 3 times. So N is 3. What's our probability of success on a single trial? Probability of success on a single trial. So what's the probability of getting 6? So you have 1 6, right? Out of a total of 6 possibilities. 1, 2, 3, 4, 5, or 6. So 1 in 6 chances of landing on a 6. Okay, so what's 1 divided by 6? 1 divided by 6 is 0.16 repeating. Is that right? Yeah, something like that. Where's my calculator? There it is. Here, let me do it on my calculator. Calculator is broke. There it goes. 1 divided by 6. It's about 0.167, roughly. Okay, I took it to 3 decimal places. So Q, then, that's the probability of failure. You take 1 minus P, 1 minus 0.167. So Q is going to be 1 minus 0.167, 0.833. Okay, so there you have it. Here's everything that was asked for. Your random variable X tells you the number of 6s you're going to get, the number of successes you're going to get. The number of trials was 3, right? That's the number of coin tosses. Your probability of getting a single 6 on 1 trial is 0.167 roughly, and the probability of not getting a 6 is 0.833. Okay, so let's do a third scenario. So what do we want to do on this one? A what? A card is drawn 4 times with replacement. That means we take out a card, we put it back. We take out a card, we put it back. We take out a card, we put it back. We take out a card with replacement. We're interested in getting an ace. We are interested in getting aces. So X, that's my random variable, my binomial random variable. That's what I'm interested in. That applies to what I'm interested in getting, right? It's the number of aces that I would get. Number of aces that we get. That's on what? 4 draws. 4 draws. So N is the number of trials, right? That's going to be 4. Card is drawn 4 times. So N is 4. And what do we want to do next? P, that's the probability of success on a single trial. There are 4 aces, right, out of 52 cards on each trial. So 4 out of 52, we'll go ahead and divide that out. 4 divided by 52, approximate that. That's about 0.077. In Q, then, that's the probability of failure. It's going to be 1 minus 0.077. In other words, 1 minus 0.077, 0.923. Yeah. There I have everything, all the important information. Okay, so I think I'm going to stop this video.